Good afternoon or evening. How are you?
Hi, Rich.
Good evening, Rich.
Hi, everyone.
Hello, Wallace. Good to see you.
Oh, same.
Is everyone having a good weekend so far?
Yes, plenty for that.
Only 2 hours, 3 hours.
Sorry, I didn't understand.
I said it's for me only 2-3 hours of the week.
Oh, yeah.
Yeah, that's true.
So I'm in the middle of the morning here.
That's what 3 o'clock here today. So I haven't even done much this weekend, to be fair. It's a long weekend as well. We've got a bank holiday on May, so I'm off work on Monday. But I've got stuff to do anyway with the new house. So yeah, just busy. But yeah, other than that, nice and easy and relaxing. I'll tell you what have we got in? We've got 5 people. Valen's just joined. Great. So just to catch up, this week, last week people were experimenting with the voting classifiers and the stacking as well. So today, Oasis, if you can take us through what your team have put together and anything else, and anyone can as well, if anyone else has done anything, please feel free to share it. And from this week, over the next 2 weeks, we're going to focus on starting to prep the deployment aspect of it. If you haven't seen already, Oasis made a start of putting something together in Streamlit and through Gradio as well. So that's quite interesting to see. So yeah, that's what we're going to focus on. Hopefully not the Saturday coming, the Saturday after will be our sort of final presentation where we basically go through all the work that we've put in and demonstrate the web app and how it functions and whatnot. So we've got 2 weeks left, and I think it's a nice time. A lot of work has been done already, so there's no mad rush to the end. We can take our time with it. For those who've never created any sort of dashboard or web app, it's the perfect opportunity to learn with Oasis now. Oasis is in previous Omdena challenges has done really well, and from what he's shown us so far, it looks like the dashboard for this project is going to be fantastic as well. So yeah, please reach out to Oasis, and I'm sure he'll share his work with you, and you can see what goes on and how it's put together and how it functions and how you extract the trained model and put it on Gradio or into Streamlit to use for inference kind of thing. So yeah, reach out to Oasis on that. But I'll let's try and get this done as quickly as possible. So Oasis, do you want to go over what the team has done over the past week or so, and any sort of preparations you've got for I'll tell you what I need to do first. Let me just allow you to share your screen. There we go. And any other preparations you've done for the web app and whatnot?
Yeah, so I have personally run a few experiments today for the voting classifier, and I know that Wallace, Soumya, and Damir also has posted their experimentations in the dashboard. So what I'm going to do is that I will quickly go over the experiments that I performed today, because I conducted around 7 to 8 experiments, and I can share Soumya's and Wallace and Damir's results, but if they can present it in more detail, then they can go ahead and do that. I will share the screen now. So let me just, yeah, so this is what I have done. So the structure of all the notebooks are the same. I have just changed the combination of different classifier that I have used in the voting classifier. So I will just quickly go over the results. In this one, this is the one that I have presented in the previous meeting. So XGB, KNN, logistic regression, and multi-layer perceptron. And this is the results that I was getting with this combination. Then I tried replacing logistic regression with naive Bayes, and these are the results I was getting with this combination. So then this is replacing logistic regression with naive Bayes was not a good idea. As you guys can see, the results are not good for this one. Then today I started doing more experimentations on it. So not this one. Yeah, so what I did is that I used the same combination XGB, Canon, logistic regression, and MLP, but this time I scaled my features, my Xtrain and Xtest. So my Xtrain and Xtest are scaled this time. So we can see the results have improved slightly. For the first one, I was before scaling the features, I was getting 98 false positive, and after scaling the features, I have 82 false positive. So, and this is by far the best scores that I have gotten. So after that, I tried a few more combinations. Like in this one, I have only used 3 XGB, logistic regression, MLP, and these are also decent, but not the best results. And after that, I tried another combination. So I introduced random forest in the voting classifier along with logistic regression, MLP, and XGB. And these are also decent, but again, not the best results. And after that, what I did is I kept the result that I was getting with the best results that I was getting. I only used those classifiers, but instead of voting is equal to hard, I experimented with voting is equal to soft. So there is a slight difference in the result that we get from using hard and soft voting classifier. So the soft basically aggregates all the probabilities that we get from all the outputs, and hard considers the concrete one or zero. So hard is not probabilities, and soft consider probability. So I was expecting to like get a bit maybe better scores, because maybe the probabilities may have I was just hoping it may have like made some effect on the results. But again, uh, I did a couple of experiments with this voting is equal to soft, but the results are not as good. So the best results that I have right now is this one. So from my experiments, I will be moving on with this one, as long as like if no one else has come up with better scores. So this is the model that I was thinking to like move on with. So I will save this model as a pickle file and use it in the dashboard. And yeah, so these are all my experiments. I have uploaded them all to the project's GitHub repository. And like I said, there has been some experiments done in the channel as well. So this is Damir's experiment. I think he has experimented with stacking, not voting classifier. So the results are you guys can see it's not the best results, but it's still good that we know now. We know that stacking was also not a good option for our project. So yeah, so these are the Damir's results. And Yeah, these are Wallace's results. So Wallace was getting decent scores, but again, I think the one that I trained was achieving I'm not sure. Let me just check. I think the best one that I had was, yeah, so it's still slightly better than this one, but these are still decent scores. So Wallace has also done experimentations, and Soumya has also done some experimentations on the voting classifier. Let me see if I can find, yeah, here. So this is Soumya's results. So the overall summary of the voting classifiers is like we are not able to get any better scores than the ones that I just shared with you, which has false positive, only 82 false positive. But everyone has done a lot of experiments, and that is good, because now we are almost sure that not like neither stacking and not a lot of voting classifiers are doing well for the data. So knowing is also a good thing. And yeah, so that's all. If anyone wants to like present their findings in details, they can go ahead and share it.
Thanks very much. Always. That's really good. Loads of experiments. The more experiments, the better. And I'm very happy with the results that you've got. Yeah, it is always said, if anyone wants to jump on and show their results in a bit more detail, please feel free.
I go. You want?
Yep.
Okay.
Go ahead.
Which one? Yeah.
From my side, I'm okay. So always presented a very nice summary of that. So I don't need to add anything else from my side.
Cool.
So do you see my screen?
Yep.
Look, just close my things. So okay, so we don't need this part. Sorry guys, now I'm with so many things going. So what happened with me, I had to switch from call-up to my laptop and do that, finish there. So what I tried to do, I tried to do classifiers, and first I wanted to do parameter tuning of each classifier, of each estimator, and then do the stacking. So this first part here, just going through all these classifiers, preparing them. That takes some time. I just want to come to, let's say, try to find MLP, because I have an interesting thing there. Okay, just regression. So these are all preparation here. Random forest. I think MLP should be somewhere out there. Yeah. So I got. I tried two with the different hidden layer sizes. One was 10, 10, 10, and then the other 150. So I got slightly different results. I left to use 150, but I'm not sure which results I should go, because these are not too bad, 0.69% for a recall. But then the one that I didn't use, it's this one here with the 72. 95. So, but this one get a lower accuracy. So it was which way to go. So you can really spend so much time playing all this. So I used the first one here, and when I was calculating, doing this scoring, I was using F1 macro this time. So it's not just the F1, just the F1 macro to get maybe a little bit better towards recall. So these are all preparations, and then we will come to the point. Okay. So now we are doing stacking here. I'm preparing the parameters that I got there before. So these are these parameters from the hyper tuning, creating the estimators. And then here I was checking what we got there. So that's why in a thing that I sent on Slack, I had to do from my laptop. So I think MLP is slightly changing if I do this on my laptop or a color. Others are staying the same. So these are the evaluation of all these after tuning. And now I'm doing stacking and just with the default XGBoost. I didn't change anything on XGBoost just for GPU usage. And these are the results of stacking with the XGBoost now, default XGBoost. Then, and you can see these are these results that I posted. Now, after that, I wanted to do tuning. Yeah, I want to do the tuning with the starting with this space for the XGBoost. So then each of these on Colab lasts 24 minutes, each fit, each trial on my laptop, 20 minutes. But then I started on both because I was expecting that Colab will cancel me overnight, and that's what happened. So then I went to my laptop where I worked, let run maybe overnight, and it worked there. And we can see here. So it's the same thing here, and it was running. And I was able to get 20 trials overnight. And the best F1 macro was this one, almost 80%. And that's the parameters. And then I was getting this refit. And so this is the one that I got after tuning. So I got much better accuracy, almost 88%, but I lost a little bit on the recall. You can see when I put them together, those two like so you see this is without tuning, recall is slightly better, and this is after tuning. I lost the recall, but I got here a little bit on the majority class. So accuracy 87.9 something, and this one is I think 87.2. So this is now I think you might get probably better results if you find better scoring going with the recall or which one to get, you know. So it's just a lot of times, and I don't know how much you get, but it seems that voting results are slightly better. So it's obvious that with the stacking you get a little bit better result than just the regular classifiers. But in our case, it wasn't, I think, good enough. So I don't know if.
Yeah, that's cool, but that's, you know, one of the things you have to consider as well is, you know, if you're going to stacking is, you know, as you've seen, computationally expensive. and it's only pushed out a very minor amount of improvement. So it's one of them again. Do we need to do it? And that's why you'll very rarely, if at all, find stacked models in production in industry, because yeah, it might be the difference between winning and losing a Kaggle competition. It might be good for experimenting and demonstrating how things work and how different algorithms complement each other. But you know, if you're working in industry and you want real time, sort of quick predictions and inference or whatever it is, a lot of the time it's easier just to really knuckle down with one particular algorithm that fits in, you know, fits whatever task you're trying to do. I've never come across a stack model in production in industry. They do exist, but I've never actually worked for one, and it's mostly because it is expensive to do. It takes a lot of time to run these experiments. Like you've just done there, you've tried to fine tune every algorithm before stacking it to get the best results, and it does take a lot of time. It takes a lot of computational power, and it may not benefit greatly. Yeah, another 1% here or there, that's great, but in real life, in reality, is that going to make a massive difference? Not 99% of the time, no, it's not. But
no, I think probably the best outcome that I get from this, that I learned a lot.
yeah. No, that definitely, and that's what part of the game is. It's learning how to do it.
What I want to mention, when you do with Omdena, it looks like that it does nice job, but it just does a nice job if you give it a nice space.
Yeah.
Space apart. I took the random forest, just a very fast copy from Google. This space put there. I got accuracy 74%, and default random forest gives you 84%.
Mm-hmm.
And then I was looking, gosh, what's changed? And then I changed a little bit, and I went to 85, 86 with a good space of parameters.
Yeah, absolutely
so
correct.
That means, you know, you really have to understand the algorithm, your data, to put the good space parameters, and then you can run a tune, and then you might get.
Yeah, well, that's it. Yeah, because you know, if you only put a small sort of search space, you are going to bottleneck it, and it can only, as you say, only search within these particular parameters. But if you know, give a depending on what algorithm it is, if you understand your data and you know what you want to try and get out of it, you can set certain parameters that are going to work for the algorithm. Otherwise, you'll probably do more damage than good, to be honest. But yeah, as long as you've learned something on how to put that together, that's absolutely great. But you know, I was going to say, on the other hand, in the sort of medical world, how good your model is life or death. And you know, generally, if you're working in a marketing company or whatnot, the very small amounts, like 0.5% and things like that, aren't going to make a massive difference. But in the medical world, they do, and that is part of why, you know, it's a good idea to try these stacking things, because if we come up with a solution and we can save a model from that outperforms a single model, that's great. You're going to be saving more lives, basically. That's what it comes down to. But yeah, that does have to be taken in you know, in consideration when you were designing machine learning models for medical uses. And you know, another step in this bit would be, if you got a model that is performing well, you're happy with it, it's saving lives, or well, it potentially can save lives, you will then have to calibrate it with the background, usually with like the background ratio of whatever disease. Use things like isotonic regression and whatnot, and that will bring in your predictions in line with what is expected. So it'll bring your predictions in line with the domain knowledge. So say if you've got 100 people, and the background in society that's been monitored, say like 1 in 100 people get this particular type of cancer. If your model is predicting that, maybe 5 to 10 of them will be getting this cancer, that isn't, your model might not be, the logic of your model is absolutely fine, but what we have to remember is it's a known that these are the particular rates. It could be a coincidence, but it's more likely not. So that's why you need to also, before your medical algorithms get deployed, you need to calibrate them against the background, which is a whole entire problem in itself. It's quite difficult to do. But it's them sorts of things. So that's why you need to get your model as accurate as possible, because once you calibrate it, there's no room. It doesn't give it any room for sort of half truths, if you know what I mean. Everything has to be dead on. And going away from this project, once this project's complete, I would, if you want to work in the medical industry through machine learning, AI, or whatever it is you want to do, calibration of your model is massively important. It's important everywhere, but it's exceptionally important in the medical industry. So it's definitely something that would require further reading, and I would recommend that you familiarize with it. So yeah, I'd look into that next. Wallace, have a good one. It was good to see you. I'll see you soon. Oh, he's left already. Anyway, but yeah, no, that's really good work. I'm very impressed with the amount of time and effort you put into that. It's superb, and that's exactly what it's about. It's just
the only thing that I have to do now is somehow to merge those two notebooks so that I can post them somewhere. So I will be playing.
Yeah.
Just to make it somehow like a document, something that we all have.
Yeah. I think as well. Now you've mentioned that. What we should do with the web app that we're going to do for the deployment, it would be a good idea to write some sort of documentation along with it that documents all the team's best experiments. It's a nice sort of track record that you can show other people as well, and it's just good for someone who may be coming across this, maybe a prospective employer may look at it and say, yeah, it works great, but who's done what kind of thing? And if you've documented your experiments in your own little section or something, I don't know, we can work out how it's going to work. But I think that'll be great, and it'll be good for you as well to sort of reflect on what worked and what didn't work, and whatever did work, you can take that forward onto other projects or in your work and life and whatnot. So I think that would be a very good idea if everyone could give Oasis a hand writing up a summary of their work and experiments. But yeah, absolutely. As always says, you've spent a lot of time, and it's very appreciated, and it's impressive as well. It's really good idea to tune every individual model before stacking it. Fantastic.
And then as you try this tuning, this stacking, it takes time because it has to go every time through all these models.
Yeah.
So 20 minutes on my laptop. A little bit longer on the call-up if you can get everything.
Yeah. Well, sometimes it's quite nice when you work in industry and you've got loads of models to train. You have to set them all to train, and you can't do much then. Do you know what I mean? So you could have a good few coffees and whatnot.
And overnight, they will cancel you after some time.
Yeah.
So that's why I did it on my laptop, and so I wanted to have some results for today.
Yeah. No, that's cool.
So I was able to run only 20 trials, but it will not squeeze too much more.
Yeah. You don't. Yeah. No, it's good as long as it's been thoroughly experimented with, and you've got decent results, and when you're trying to squeeze, not even a full % out your model, that's when you sort of have to call it quits. Wait, I've just seen that you raised your hand.
Yeah, so if I can have the screen just for a second, I want to show everyone what we have achieved from the beginning to like until now. So this is what we had in the very beginning before doing any augmentation on the data. the best model that we had was it was actually good, and this was the score. Then after performing augmentation, we can see that there was a slight improvement, not a lot, but at least it confirmed that augmentation did play a little role in improving the results. And then um, this is what we have right now. So after augmentation and voting classifier, so we can see that our results have improved even further. So this is just to show everyone that everything that we have done from the beginning of the project until now, so most of it has paired out. So yeah, so it's just I wanted to show a comparison between the beginning of the project and what we have at right now.
Yeah. No,
So
that's a really good idea because it is hard work. It's sort of we've lost quite a number of participants on the way because it is difficult. Do you know what I mean? But
yeah,
that's the fruit of your labor. Now, let's imagine if we were all working together on the same team in a hospital and we were putting this together. One of the biggest sort of Achilles heel that we've had is that the data was unbalanced and there's no way to other, we've tried the augmentation, but it doesn't quite cut it in terms of what more data would do. So if we were a team now in real life and in a hospital, and we'd say, we've reached this plateau of performance, we can't get any better. How are we going to improve the model? What we could do is just have our hematologists provide us with more data and filter it in, make sure our classes are balanced, and maybe even get better, data that's even a higher resolution or whatever it is. We could improve our model through that. When you work with machine learning models, a lot of the time, all the time, I would say 100% of the time, you're only as good as your data, and it doesn't matter how well you build a model or build a neural network or tune your hyperparameters. If your data isn't strong, you'll never garbage in, garbage out. That's the saying. But if we're very limited in because we're on an Omdena project, we do this for fun, we do this experience and to increase our network and whatnot. In real life, we could probably take this model to another level with the right data, with more data. It's just unfortunate that we can't. But what Oasis just showed you is the fact that all the different experiments and all the different iterations have directly impacted the performance of the model and it's improved it. And that alone, if we imagine if we were doing this in real life and we were all a team in a hospital, where this work and these experiments that everyone in this room has done would potentially save lives. It would allow people to get earlier diagnostics. It would allow people to understand the disease a lot better and maybe figure out better treatment options and things like that. So it would directly save lives. And if you look at it on face value, it's not a massive jump, but 1%, say if we call 1% is an extra life saved. If you raise your accuracy by 5%, that's another 5 people whose lives you've saved or diagnosed and got the right treatment or whatever. Do you know what I mean? It's when you think about it like that, and that's why in the medical industry, it's very important to have a model with that is spot on, most of as higher accuracy as you can. So yeah, that's it. I think what you've done there always is that would be a good idea to include on the web app as well. I think it would be a nice idea if people could sort of summarize their experiments. It doesn't have to be pages and pages, maybe like 500 words summarizing what they've done, what they found what they found that did work and what didn't work, and how it's contributed to the final results. And I think including some of your slides that you just presented always in the final web app is a good idea. Let's have like we did with the previous project where we had the main functionality of the web app, but there was also a side that spoke a little about who the team was, what we did, and the various sort of phases of the project. I think including that would be very beneficial as well. and you know everyone has put a lot of effort in, and I just want that reflected within the final results, if you understand. But of course, I don't expect you to do it on your own. So if everyone can help put together a summary of what they've done and send it to Oasis, you know, he doesn't have to chase everyone up. Then it'd just be a lot easier to put it all into one place. But yeah, great work so far, everyone. And we're coming to a close now. 2 weeks, and we'll have a nice little web app that you know we can promote on our LinkedIn's, on Omdena and whatnot. And you know, it's something for your portfolio website or your resume and whatnot. So yeah, it'll be really, really, really good, I think. So thanks very much, everyone. So you've got 4 minutes left. Has anyone got any questions, further comments, or anything like that?
I have a question.
Yeah,
What
go
is
on.
the best scoring to let's say when you do a tuna parameter for this kind of data set? Like I was trying to go with the F1 macro now. Started first with the F1 that is only looking the class 1.
Yeah.
Class. So what, from your experience, what do you think that should be like?
See, with F1, now that is usually a nice metric. It is quite a balanced metric between precision recall. However, in a medical sense, generally, depending on what you want to do, you may prioritize recall, you may prioritize precision.
Mm-hmm.
Now, I shared something, I think it was about 2 weeks ago now, which sort of you could input your results and it would give you the various different sorts of medical grade metrics. There's quite a lot of them, to be honest with you. And, you know, it would entirely depend on what you want to do. And what we want to do at the moment, I would recommend, I think I've got a document what I wrote before. Give me 1 sec. Let me just see if I can.
Because I think that changes all these things a lot.
Yeah, it does. Yeah. I think I done a bit of research into it. I think, is this it? No. Yeah. So this is the paper. This is the paper what I'm talking about. Where is it? The chat. That one. So it gives you all the metrics, and looking at that, if you see like the F1 score is the mean of precision and recall, or the harmonic mean is what it is. It penalizes the values of each. But things like precision, if you were to calibrate your model, that's when you'd need precision, because you need to understand what is the accuracy of the relevant samples. Do you know what I mean? What you know, because if you calibrate your model to reflect the background rate of the disease or whatever it is within a population, you need the precision to identify them particular samples that adhere to the rate. So it very much depends on what you're trying to achieve, and there's an argument for all of them. Specificity, and you know that's the class version of recall. So F1 is a good baseline, and for most classification regression, classification problems, F1 score is quite good. But in the medical sense, in the sort of very technical industries, it might not be enough. It might be good enough to give you an indication of how your model will perform, but if you need to specify it a little bit harder to identify a disease in a particular population, that's when you would use things like precision and whatnot. So that's what I'm trying to say. It's entirely on what your requirements are. But read that paper. That's a very good paper about them. And I think we've got less than 30 seconds left on this meeting. So we can call it a day there. We'll catch up on Wednesday and we'll see how we're getting on with the web app. And make sure you write your bios and just a brief summary of your experiments as well. And we'll include them. And so, yeah, have a good weekend, everyone. And I'll see you soon.
Thank you. Yeah, bye.
Thanks.
Bye.